So we established then that current is proportional to your potential difference and inversely proportional to resistance, right? Okay, so, you know, from all this discussion, current, just from this much. You formalize this by saying the current is proportional to potential difference and I'll use an AB there because using V for potential difference, I could use a fancy E for EMF, right? But I'll use this because that's a symbol you're usually going to see when you deal with circuits, okay? It's proportional to this, right? Well, now we just declare that the proportionality constant is 1. Of course, this means that current equals K times VAB over R. Directly proportional to potential difference, inversely proportional to resistance, right? And if you don't know proportionality well enough to just take this and run with it, please, hopefully before the exam, but sometime before you go on to bigger and better things, nail proportionality, which we did in 8th grade, and the rest of the world knows. Okay? We don't do it because it's kind of hard for some people, and we can't be hard on anybody. We can't do anything that'll make somebody feel bad because they can't get it. So we never make anybody put forth the effort they need to master a tricky concept. It's not all that tricky, though. At the level of a 13-year-old, it's pretty tricky. At the level of a 18 to 20-year-old, or whatever, yeah, some of you guys are hundreds of years old, but yeah, you, you can nail this. Okay, this just means now if you got a potential difference in the resistance, you can, and a current that's associated with them, you can figure out what K is, right? And then you can apply it to any situation. So you got a formula by the proportionality. Now, we're just going to let K equal 1. So I equals VAB over R. Okay? Now, that's it. That's Ohm's law. You know, Ohm did this experimentally. Okay? So Ohm's law actually preceded the idea of conductivity historically. And usually you study current electricity starts with Ohm's law and stops there, and you never think about this, which is why I started here. Okay? Because if this is all you know, you never get anywhere. It's harder to move from this to this than it is to move from this to this. This part is easy. Okay, so what are the units? Must be units of VAB over units of I, right? So that's joules per coulomb over coulombs per second, which is joule seconds per coulomb squared. And you can reduce that down to kilograms, meters, seconds, and coulombs, right? That's just a kilogram meter squared per second squared. That's a second, so it's a kilogram meter squared per second per coulomb squared. Or kilogram meter per second squared per that's a kilogram meter per second coulomb per quantity second coulomb squared, right? I'll get it right. So I think, you know, that should be kilogram meter second coulomb. Or ohms.
Should it only be 1 coulomb? No, never mind.
No,
Never
yeah.
mind.
Okay? There's only one Coulomb, but it's squared. But yeah, and that was what you meant. Okay? Now, I'm going to leave you to look at the rest of this, because I don't want to spend the whole class on it.